For centuries, an excellent house or building was defined as a brick structure. Nothing else has ever matched brick, and brick alone in its mastery of structural strength, durable permanence, and traditional beauty. This video is your guide to proper construction techniques, which are found in residential masonry construction. The Brick Institute of America presents Residential Brick Construction. Our presentation covers important key components you need to perform brick masonry projects successfully. Since many lessons are learned from mistakes, this video includes some of the problems created by not following proper construction procedures. Of course, we've designed to include mortar mixing, wall types and moisture resistance, flashing and weep holes, wall ties, the support of brick, expansion joints, and arch details and construction. Mortar mixing. Mortar is the material that binds a brick wall together. It is important that the mortar bonds to the brick so it can weather port loads. The mortar joint also accommodates variations in brick size. Mortar makes up to 20% of the area of a wall, so the quality and consistency of the mortar greatly affects the wall's appearance. Each ingredient in the mortar plays an important part. The ingredient which provides bond and gives the mortar strength is the cement. Two types of cement are used in mortar: Portland cement and masonry cement. Portland cement is used in combination with hydrated lime and sand. Type 1 Portland cement is typically used in mortar. Hydrated lime is used with Portland cement to make the mortar more workable. Mortar requires Type S hydrated lime. Masonry cements are combined with sand or combined with Portland cement and sand to make mortar. Types N and S masonry cements are used in mortar. Sand's most of the volume in mortar and makes it economical. Mason sand should be used, and it should be free of contaminants such as salts, clays, or other debris. Sometimes admixtures are considered for use in mortar to change certain properties or for the ability to build during cold weather. In most cases, admixtures are not helpful to the performance of the masonry and in some cases hurt performance. There are alternatives to using admixtures. For example, to increase workability, use a wetter mortar or slightly increase the proportion of fine sand in the mix. For cold weather construction, heat the sand or water instead of using an admixture. Color pigments are admixtures that can be used in limited quantities. However, you'll obtain the easiest control of mortar color with a pre-blended colored Portland cement or colored masonry cement. Getting good performance means proper proportions of each of the ingredients. Types N and S mortars are generally recommended for residential construction. Their proportions are as you see here. Although Portland cement creates bond, too much cement may make the mortar harsh. More cement will cause the mortar to shrink more, which may result in hairline cracks, the result of too much cement being used. If too little cement is used, the mortar bond will be poor. The brick on top shows good bond between the brick and mortar. The brick on the bottom shows no bond between the brick and the mortar. Hairline cracks and poor bond allow water to penetrate. The amount of sand used in mortar is also very important. If too little sand is used, shrinkage will be a problem. Too much sand reduces strength and lowers durability. The amount of sand that you can measure with a shovel is usually inaccurate due to the differing sizes of shovels and the inconsistent amount of sand that is picked up each time. A container like this 1 cubic foot box is preferred. It can be used to accurately measure the sand being added to the mixer. You could also count how many shovels it will take to fill the box. That's also acceptable. However, you must check this count daily because of changing moisture conditions. Of course, you must add enough water to the mortar to provide a good working consistency. The mason will usually know the right amount of water to use. Always add materials to the mixer in the same sequence, and fill the mixer to the same level to give consistent mortar. This is especially true of colored mortars. Retempering or adding water to the mortar after initial mixing can be done. This allows the mortar to remain workable. Discard mortar 2.5 hours after it is initially mixed. By using the proper materials, proportions, and procedures, the mortar will be more consistent from batch to batch, resulting in good performance and good appearance of the wall. Wall types and moisture resistance. From the outside of a house, all walls may look alike. However, there are two distinctive wall types used in residential construction: the drainage wall and the barrier wall. Each wall type handles water resistance differently. With drainage walls, we assume that water will penetrate the wall. Clear air spaces, flashing, and weep holes are relied on to keep water from entering the house. The brick veneer wall you see here is an example of a drainage wall. They provide better water penetration resistance than barrier walls. Barrier walls, on the other hand, use their thickness to act as a barrier to water. A collar joint is the space between the withes, and it's the primary barrier to water. If there are holes in the collar joint, or unfilled mortar joints, water leakage can occur. Here's an example of a barrier wall. To perform properly, the collar joint has been totally filled with mortar or grout. Water leakage in a house can be a major problem. Water can ruin interior finishes such as drywall or carpeting. It can cause damage to sheathing materials, which results in mold and fungus growth. And it can even cause corrosion of metal items in a wall, such as wall ties. Water takes the path of least resistance. Leakage usually occurs through unfilled mortar joints, around uncaulked windows and doors, and through hairline cracks in the mortar joints. Although the brick itself will absorb water, it will not leak. Water usually gets in between the brick and the mortar, not through the brick. Most residential construction uses a drainage wall. The wall is typically a brick veneer over a wood stud backing. However, concrete block may also be used as a backing. The drainage wall has a 1-inch airspace, which must be kept clear. Mortar bridging across the airspace, like this, provides a path for water and leads to water penetration problems mentioned earlier. There are several methods to keep the airspace clear. The easiest way is to bevel the back side of the mortar bed joint. Use a trowel to slant the mortar joint away from the airspace. When the next brick is laid, very little mortar squeezes out from the back side of the mortar bed. Of course, other techniques exist. Many are designed to prevent or correct problems that would happen only occasionally, or they've been developed by the bricklayer or the mason as a personal style. Whatever method is used, the airspace must be kept clear of mortar. In all cases, the bed and head joints should be completely filled with mortar. Clipping the head joint where only a small amount of mortar fills the joint is poor construction practice. Full joints will make it more difficult for water to penetrate the wall, reducing the chances for problems. Another technique which affects water penetration is the proper tooling of mortar joints. When the mortar is thumbprint hard, the joint is tooled with a metal jointer. Tooled concave and V-shaped joints are the best to resist water penetration. Other joint types, such as raked joints, do not compress the mortar and therefore allow more water penetration. A drainage wall requires a moisture-resistant sheathing, or a membrane, which covers the exterior sheathing. The sheathing, or membrane, must resist any water that gets across the airspace. The sheathing, or membrane, must not have holes or punctures in them where the water could penetrate. Membranes are usually 15-pound building felt. However, it could be a product such as Tyvek, an air barrier that also resists moisture penetration. These materials must be lapped properly to shed moisture. The drainage wall must also have flashing and weep holes. Flashing and weep holes are located at the base of the wall, over windows and doors, and other interruptions in the airspace. If flashing is not installed, water which penetrates the brickwork will usually end up inside the house. In some instances, the bottom of the airspace is covered with a granular material like pea gravel or plastic netting. This material will keep the weep hole from being blocked by mortar droppings. Any material used should be free from contaminants such as salts. The proper performance of a wall is determined first by the wall type used and second by proper construction of the wall. If all these procedures are followed, complaints will be kept to a minimum. Flashing and weep holes. Flashing and weep holes are an important part of any masonry wall. The purpose of flashing is to direct water that has penetrated the exterior withe back to the exterior. Thus, they are required for proper performance. Different types of flashing materials are available. These include copper composites and sheet metal flashing, and plastic flashing like PVC or neoprene. Thicker flashing materials should be used since they will not puncture easily and will last longer than thinner flashings. Building felt and polyethylene sheet should not be used as a flashing material. They can be easily punctured and deteriorate quickly. Aluminum should not be used. It corrodes in fresh mortar. And here are the locations where flashing must be installed: at the wall base, over windows and doors, under sills, at roof intersections, at chimney and roof intersections, and under wall and chimney caps. Some building codes now require flashing to be installed in residential construction. If flashing is to work properly, it must be installed properly. Since water can flow along imperceptible slopes, end dams and sealed flashing are critical. Where flashing is not continuous, such as above windows or at window sills, the ends of the flashing should be turned up to form a dam. The end dam forces water back out of the wall through weep holes. The end dam only needs to be turned up a couple of inches into the head joint. Where flashing is continuous, at the wall base for example, sections of flashing from a roll must be lapped and sealed to prevent water working its way beneath the flashing sections. The flashing must be lapped a minimum of at least 6 inches and then sealed to be effective. Use a mastic to seal the flashing sections together. The flashing must also be turned up at least 8 inches and attached to the backing. Otherwise, water could build up on the flashing and enter the house. Flashing should be placed behind the sheathing or sheathing membrane. It should run under the brick to the face of the wall to form a drip edge if possible. Don't stop the flashing back from the face of the wall. Flashing that is held back from the face allows water to bypass the flashing and re-enter the wall and house. Flashing can be installed with the edge protruding from the wall and then cut flush when the wall is complete. A common misconception is that the flashing breaks bond in the wall, making the wall unstable. Although bond is broken, the wall will remain stable if properly supported and properly attached to the backing with ties. The weight of the brickwork holds the wall in place. Flashing is important at the base of the wall, not only for getting rid of water, but to break bond with a concrete or concrete masonry foundation. The concrete will shrink, and the brick will grow, causing the foundation to crack unless the bond is broken. Where roofs and walls or chimneys intersect, through-wall flashing and counter flashing must be installed properly to avoid the damage of water penetration, as you see here. Through-the-wall flashing is necessary to direct water that has penetrated the wall above the roof back out again. The roof counter flashing is not sufficient to stop water that runs down the interior face of the brick. Through-the-wall flashing will force the water out through the weep holes. Roof flashing is lapped under the shingles and continues up the wall several inches. The counter flashing is placed under the through-wall flashing and comes down over the roof flashing. Weep holes function to remove water from the airspace as quickly as possible. They're only useful if used in conjunction with flashing. Weep holes can be open head joints, rope wicks, weep tubes, vented weep holes, or rope wicks which are pulled after installation. The larger the weep hole, the easier it is for water to exit the wall and the less chance for mortar droppings to block the weep hole. Open weep holes could allow insects to build nests in the hole, clogging it up. You can prevent this by using copper screening, stainless steel wool, or vented weep holes in open head joints. Thus, Proper flashing and weep holes are necessary to get rid of water that has penetrated the brickwork. Its correct installation will avoid many of the potential water-related problems. Wall ties. Wall ties are essential structural elements which attach brick to its backing. Ties transfer wind and earthquake forces on the veneer to the backing. When ties are not installed properly, the brick wall can fall away from the house. It can also cause cracking to occur in the brick wall. Several recent hurricanes showed the importance of ties when the wind pulled the brick from the house because of poorly installed ties. There are many different types of wall ties. Corrugated sheet metal ties, flat sheet metal ties, and wire ties connected to a backing plate are the most common. Wire joint reinforcement is also used as a wall tie when brick and block walls are constructed. Corrugated metal ties are the most common type of tie found in residential construction, but corrugated ties require close attention paid to their installation. To be effective, the nail used to attach the tie to the stud must be very close to the bend in the tie. If not, the veneer can move too much before forces are transferred to the framing, causing the brickwork to crack. Corrugated ties must have a thickness of at least 22 gauge and be at least 7/8 of an inch wide to meet building code requirements. Thicker metal ties are desirable to transfer wind forces better. Thicker corrugated ties are more difficult to bend, so pre-bent ties should be used. All ties are required to have an adequate galvanized coating. The corrosion resistance of corrugated ties is usually poor. The galvanized coating is often cracked or knocked off when the tie is bent. If this happens, the corrugated tie may corrode very quickly. Therefore, ties which are pre-bent are preferred to those that must be bent in the field. It's important to attach the tie to the backing properly. When building with wood studs, nail the tie to the stud. Nails can easily pull out of the sheathing, so they must penetrate the studs. Ties used in concrete masonry backings must be properly embedded in the mortar joints. Wire ties are used with a backing plate. Attach the plate to the stud with 2 nails. All ties must also be properly embedded in the brick veneer. The tie must extend into the brick with at least 1½ inches into the mortar joint. However, the tie must not come closer than 5/8 of an inch from the exterior, so it's protected from the elements. Mortar must completely surround the ties. This reduces corrosion and provides good load transfer. The building codes require that the tie be installed at specific spacings, both horizontally and vertically. Most codes require at least 1 tie for every 3½ square feet of wall area. The horizontal spacing should not be greater than 32 inches, and the vertical spacing should not be greater than 18 inches. Wall ties are installed to attach the brick to the frame. When installed correctly, cracking and other problems will be less likely to develop. The support of brick. Brick must be properly supported by foundations or structural members in order to prevent cracking or stability problems. In some severe cases, the result is the masonry falling off the house. Not only must the brick have sufficient bearing, but steel lintels supporting the brickwork must be properly attached to the structure. Here are some indicators of improper bearing conditions: bowing walls, cracked mortar joints, or cracked units. At least 2/3 of the thickness of the brick withe must bear on its support. If it overhangs the support more than this, the wall may rotate and crack. Masonry or concrete foundations should be made wide enough to allow proper support of the brick. For a 4-inch nominal brick, there should be at least a 2½ inch support for the brick veneer. Masonry must be supported on adequate foundations. Foundations such as this are never appropriate. The top course of masonry foundation walls must be solid units or hollow units filled with grout so the brick has full bearing. The hollow units on this project will be filled with mortar or grout. Where proper bearing on the foundation is not possible, alternatives should be considered. These include corbelling the brick off of the foundation or bolting a steel angle onto the foundation. Brick should never be supported on mortar built up on the outside of the foundation, nor on insulation, nor on 2x4s or other non-rigid support. The same bearing rules apply for bearing on lintels and other means of support. At least 2/3 of the brick thickness must rest on the horizontal leg of the lintel. Steel lintels used to support brick over windows and doors also require proper bearing on the masonry jambs. The ends of the lintels must bear on the brick wall below at least 4 inches. Larger lintels over garage doors may require longer bearing lengths. It is often desirable to place masonry on the side of a house over a lower one-story portion. This creates a potential problem of supporting the masonry. Most building codes require a non-combustible support for brick. This problem also occurs over bay windows and similar architectural features. Many builders try to support the masonry directly on the roof of the lower portion, which may lead to problems. The best way to solve this problem is by continuing the end wall down to a foundation or footing. If the opening is short enough, a steel angle can be used to support the brickwork over the roof or opening. In some cases, the choice is to support the brick veneer on the roof's framing members. While this can be done, it may conflict with the local building codes. This alternate means of support must be approved by the local building official. The preferred means of supporting brick on wood is to have a steel angle bolted directly to the wood framing members to support the brick. The wood framing members are designed to resist the load. As an alternate, a steel angle may be attached directly to a roof rafter. The rafter must be strong enough to support the load. The brick must bear on the rafter and not on the roof sheathing alone. In all cases, through-wall flashing and counter-flashing are very important to reduce water penetration. The brick supported on the wood must be separated from brickwork supported on the foundation by a vertical expansion joint. Without exception, through-wall flashing and counter-flashing are very important to reduce water penetration. Brickwork must be properly supported to avoid problems or failures. A strong, rigid support is necessary to achieve adequate bearing. Expansion joints. All building materials move due to temperature or moisture changes. Some materials, such as metal or wood, move more than others. And when these materials are used in large areas, they can move enough to cause problems, such as cracking. That's the reason for expansion joints, to avoid cracks. Occasionally, movements will be large enough to cause cracking in the brickwork. Cracks often occur around window openings due to differential expansion, or near foundations due to settlement of the foundation. However, these cracks can also occur in many other locations for various reasons. The movements are caused by a variety of factors, including thermal expansion and moisture expansion. As you know, materials will increase in size when heated, and metals expand at a much greater rate than brick. So, when metal is embedded into masonry, it may cause cracking. Railings embedded into the brickwork often will crack the brickwork it's attached to. The brick also expands when heated, usually about 1/2 inch in 100 feet. Some materials expand or contract with a change in moisture. A brick is the smallest it will ever be when it comes from the brick plant. It will continue to increase in size over a prolonged time period. Most of this expansion occurs within the first few months, and then very slowly after that. The brick could expand up to 1/3 of an inch in 100 feet due to moisture expansion. Concrete masonry, and wood shrink over time. The shrinkage is opposite to that of brick's growth. So, essentially, we add together first the positive growth of the brick with the negative shrinkage of the concrete masonry or wood. To avoid cracks, a series of movement joints should be installed in large masonry areas to allow the movements to occur. Two movement joints are used to accommodate these movements: expansion joints and control joints. Expansion joints, as the name implies, allow expansion to occur. They're used in brickwork and are filled with materials that can compress. Control joints, on the other hand, control the shrinkage of concrete and concrete masonry. They may be filled with hard materials, such as special hard rubber pads or mortar. Expansion joints and control joints are different and should not be used interchangeably. Expansion joints are usually not necessary in small to medium-sized houses. However, if there are large expanses, many returns, or different support conditions, then expansion joints should be used. Expansion joints are usually placed in walls over 30 feet in length. They are installed at corners and at offsets or returns in long walls. Expansion joints should be placed where the brickwork is supported differently. Here, the garden wall is supported on a separate foundation from the house. The garden wall foundation settled, causing a crack at the intersection. Installing expansion joints is relatively simple. In most cases, the expansion joint is formed as the wall is constructed. A 3/8 to a 1/2 inch wide gap is left, making sure that no mortar clogs the joint. Any mortar or ties which bridge the expansion joint render it useless. A soft foam pad may be used to help keep mortar out of the expansion joint. Any joint reinforcement should also be terminated at an expansion or control joint. After the wall has been laid up and cleaned, a backer rod and sealant are placed in the joint. A backer rod is a soft foam rod used to keep the sealant at a constant depth. A good grade sealant is then used to fill the joint. If installed properly and at the correct locations, expansion joints can eliminate many cracks in brickwork. Arch details and construction. Brick arches evoke a rich history. Many ancient structures used brick arches as a means of structural support. In the U.S., many colonial buildings incorporated arches in their design. Many of these older arches were in brick-bearing structures with thick walls and usually did not have any problems. However, today's arches are usually only 1 wide thick and are often supported by slender columns. Problems have arisen where improperly supported arches have collapsed. Other critical elements are flashing and construction of the arch. Arches work if designed and constructed properly. Many different forms of arches are available: jack arches, segmental arches, semicircular arches, and other miscellaneous types. The structural design of an arch is a complicated procedure. The arch should be designed by a structural engineer only. An arch works to resist vertical loads by transferring the vertical load and developing horizontal forces or thrusts. The vertical load and the thrust to be resisted depend on the arch span, the arch rise, and the magnitude of the vertical loads applied. The arch must have several features in order to work properly. It must have sufficient height of masonry above the opening. The ring must be of sufficient thickness. A rowlock course is usually adequate. And there must be sufficient masonry at the ends of the arch to resist horizontal thrusts from the arch. In residential construction, the most common problem is too little masonry to resist the arch thrusts. Arches often abut or sit on columns as an architectural feature. But unless the brick veneer which surrounds the wood column is braced, it may not be strong enough to resist the thrust from the arch. The abutments rotate, giving rise to cracks and a possible failure. Other means of abutment support, such as a roof or window frame, are usually not adequate. Construction of arches is usually done with centering. By centering, we mean the technique of cutting wood pieces in the shape of the arch and then laying the brick on the wood forms in the desired pattern. The centering is left in place for 7 to 10 days for the mortar to harden. Although flashing is difficult to install over a curved opening, it must be installed just as over any window or door opening. Through-wall flashing should be installed in a stepped fashion over the arch or laid in a horizontal line just above the top of the arch. Properly designed and constructed, arches add a touch of elegance to brickwork. As we've said, nothing has ever matched the beauty and structural features of brick in residential construction. This video has just presented information that's essential to achieving it. Our topics included mortar mixing, wall types and moisture resistance, flashing and weep holes, wall ties, the support of brick, expansion joints, and arch details and construction. The keys are knowledge and experience.